Hello friends, this is the electricity part 4. So before you are going to deal with the part 4, make sure that you have watched all the previous videos. So here we'll start. So students, in that electricity part 4 session, we are going to study a very important term, the very important law, which is quite important according to your point of examination. So in this part we are going to study the Ohm's law, everything about the Ohm's law. So first of all, the Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied between the end of the conductor, provided temperature remains constant. So actually friends, that what the Ohm did in his Ohm's law is actually he considered one electrical circuit. Actually he took one electrical circuit, and in that electrical circuit he's keep changing the potential difference. Got it friend? He's keep changing the potential difference, or you can say voltage, and at that every change in potential voltage he's taking the reading of current. And after that he drawn one graph in between the potential difference and current, and that particular graph is like this. Actually what that Ohm's did, he plotted one graph like this, the graph between the potential difference and the current, and for the different values of V, for the different values of V, he got the different values of current. And when he finished this graph comes like this. This graph comes like this. This is called what? This is nothing but the linear graph. This is nothing but the linear graph. So this is the observation of the Ohms, that if you are going to increase the voltage in some electrical circuit, that with respect to current, that graph will come linear. Okay friends, so here we have to talk about the mathematical relation. According to this definition, what is there? It is there that the current flowing in this circuit is directly proportional to the voltage or potential difference between the conductor, between the two ends of the conductor. So if you are going to replace this proportionality sign with some with equal to, you have to replace this sign with some constant. So here we can write that I is equal to some constant into V. What was that constant? That constant nothing but I is equal to 1 by R into V. So linearly we can write like this, that V is equal to IR. So this is the final result of Ohm's law, friend. So here everything is quite clear, that what do you mean by V? V is nothing but the voltage or potential difference. What do you mean by I? I is nothing but current. This is a new term, R. R is nothing but here. R is nothing but this R is known as the resistance. What is this? This is called the resistance, and resistance is always a constant. Okay friends. So now one thing we have to understand here, that what is resistance actually? What do you mean by resistance? So our next question is that what is resistance? Resistance, it is the property that resists flow of current. So in short friend, you can understand the resistance is nothing but the obstacle in flowing the current. So resistance is something which offers some obstacle. Actually resistance opposes the flow of charge. Okay friends, so what is the relation between the resistance and current is that if you are going to increase the resistance, it's quite clear, if you are going to increase the resistance, the current will go decrease, and if you are going to decrease the resistance, current will going to increase. Okay friends, so before we are going to start further, you have to understand one thing. Just take one example. Okay, first of all we discuss that how resistance offer. Okay friend, so you have to take one metallic wire. In that metallic wire, that previously we have discussed that how current flows in the metallic wire. Actually it is due to the flow of free electrons. Okay friends, so in that metallic wire there is number of atoms are there. Okay friends, there is number of atoms are there, and that particular atom is having some free electron, and that particular electron will move from one atom to the another atom, and that particular atom to some another atom, and so on. it's keep on flowing like this. So you have to understand here a little bit that when the free electron will jump from atom to atom, it will collide with the nearby atom. Okay friends, and what will happen due to the collision? If the number of collisions will get increased, that means the resistance of the wire is also getting increased, and if the number of collisions are less, then only you can say the resistance is also less. So it's so that resistance property is totally depends on the collision, the number of collision. If the possibility of collision is high, that means that particular material will offer a high resistance. Okay friend, and if you are going to increase the resistance, the flow of current will get decrease, and if you are going to reduce the resistance, the flow of current is going to be increased. So that thing you have to remember every time. Okay friends, now the next thing is that resistance is the quite important term. Then we have to discuss the factors on which the resistance depends. Actually, that resistance depends on what kind of thing, what and all are the factors in which the resistance depends. So first factor, that is called the length of the conductor. That means the resistance will depends on the length of the conductor. So I'm telling here the resistance is having the directly proportional relation with the length. That means that if you are going to increase the resistance, if you are going to increase the length, resistance will also get increased, and if you are going to reduce the length, the resistance will also going to reduce. So it depends on the length. How it is possible? Okay friends, just take one small example here. Let's suppose this is some internal structure of some metallic wire. This metallic wire consists of atom like this, isn't it? This metallic wire consists of atom, and electron will jump from this atom to this atom, and this particular atom to this atom. Here the collision is there. Once the free electron will jump from one atom to another atom, definitely the collision is there. Here let's suppose here some collision is there. Okay friends, so due to that collision, this metal is offering some resistance. Okay, now what I'm doing, I'm increasing the length. If I'm going to increase the length in this manner, okay friend, so again this, if you are going to increase the length, then number of atoms will also get increased. Okay friend, so here also same process will happen. The free electrons will jump from this atom to that particular atom, this particular atom. So here the possibility of collision is less in this in this case A, and the possibility of collision is more in this case B. So this wire, this length will offer the more resistance because the collision is maximum here. So that is the proper explanation of this relation, that how length is related to the resistance. We are going to consider this is the equation number 1. Okay friends, so what is the second factor? Second factor, it depends on the cross-sectional area of the conductor. I'm telling that the cross-sectional area is having the inversely relationship with the resistance. That means what? That means that if you are going to increase the cross-sectional area, resistance will get decreased, and if you are going to decrease the cross-sectional area, resistance will get increased. How it is possible? Just take this example. This is the example of solid. Again, what I am doing this with the same amount of atom, I am going to increase the width. That is only the cross-sectional area. So if I am going to increase the width like this, and this is also having the 5 electrons, that 5 atoms which are having, so you can clearly observe that as compared to this A condition, here the more space is there to move the free electron from one atom to another atom. So in this case the possibility of collision is less, and if the possibility of collision is less, that means resistance is also quite low. Yes or no friends? So you can say that if you are going to increase the cross-sectional area, your resistance is going to decrease. Got it friend? So we can consider this is as the equation number 2. Okay friends, so now what is the third condition of resistance? That is called the nature of material of the conductor. This is the again very quite important thing, that resistance will depends on the nature of the material. That means that if you have the 2 or 3 different types of material, that is all the materials having the different resistance. Okay friend, so fourth important point, that is called the temperature of the conductor. Temperature of the conductor means that if you are going to increase the temperature, if you are going to increase the temperature, the possibility or the resistance will also get increased. How it is possible, friend? It is possible because that if you are going to increase the temperature for some solid or for some metal, what will happen? The random motion of electrons will also get increase, and if the electrons is moving in the random motion, they will collide with the nearby atoms very frequently, and again concept rise, the more the collision, more the resistance. Okay friends, so this, in this manner, resistance will depend to the temperature. Okay friend, so we know this equation first and this equation number 2. Now we are going to combine this equation together. So we have to write from equation first and second. From equation first and second, we can write that resistance is directly proportional to the length by area. Again, if you are going to remove this proportionality sign, we have to replace this proportionality with some constant. Okay friends, so here R is equal to rho L by A. So here rho is what? Rho is nothing but the constant, and this is the, again friend, this is the very important term, rho. I think first time you got to know about this that rho value. So rho is, what is rho here? Rho is nothing but some specific resistance. This is nothing but the specific resistance, and this is most commonly known as the resistivity. This is most commonly known as the resistivity. Okay friends, so this is the quite new concept for you, that rho, and there is no need to think much about the rho. Rho is nothing but the specific resistance, and this, see, below one very important note is there, that is called that rho is specific to the material. Again friend, again that the thing we have to understand here is that again this rho value is depends on the material to material. For the different kind of material, the value of rho is in totally different. So this is all about the Ohm's law, friend. This is all about the Ohm's law. Actually, that Ohm's is the complete law, but after that Ohm's is having some limitations. Ohm's is having some drawbacks. So now we have to discuss some drawbacks about the Ohm's law. So first drawback is the limitations of Ohm's law. First thing, that is called the behavior of diode. Diode, first time you are hearing this word diode, there is no need to think much about this diode. Diode is something which is having the unidirectional current flow. You see, this diode is nothing but some electrical component which is having the unidirectional current flow. This is the unidirectional current flow. No need to think much. In the 12th class physics, we are going to discuss this diode in the chapter name, which is called the semiconductor. Okay friend, how it is not following? See friend, if you are going to draw the voltage and current graph for the diode, that graph will come like this. Graph will come like this. So this is the VI graph. This is in between the V, and this is called the I. So this is the VI graph, and Ohm's clearly show that if something is following the Ohm's law, it is following the linear graph. Exactly friend, but in the case of diode, you are clearly saying that this is not the linear graph. So this is some limitation of Ohm's law. Okay friend, second thing, that is called the behavior of gallium arsenide. Gallium arsenide is some kind of material which is also not obeying the Ohm's law, which is also not following the linear graph concept. Okay friends, so third thing, which is called the in case of water voltmeter. Again, this water voltmeter is quite new word for you. Again, no need to think much, just remember this name, water voltmeter. So what is that water voltmeter? Actually, that is the process in which we are doing the electrolyzing of water. This is nothing but the electrolyzing of water. Again, this is the new term. What do you mean by electrolysis? So friend, electrolysis is nothing but it is the process of decomposition. It is the process of decomposition of water into hydrogen and oxygen. Okay friend, this is the decomposition of water into hydrogen and oxygen. So how it is not following the Ohm's law again, that voltmeter, that again if you are going to draw the VI graph for the voltmeter, the graph will come like this. Graph will come like this. This is the, again this is the voltage or some potential difference, and this is the current friend. Okay friend, so this graph again this graph is not linear, because linear graph should have to start from the origin, but this is that graph is totally different from the Ohm's law. So these are the few limitations, these are the few limitations of Ohm's law. Okay friend, this is all about the Ohm's law. I hope that everything is cleared for you. Thank you.